Welcome back for another round of Calculus with Mr. Nice. So, we've been working on some chain rule and some other derivatives and problems of that nature. Um, we've done some tangent line problems in the past with some easy derivatives. Let's do a recall with that, some of the easier derivatives, before we get into one with the chain rule. Tangent line problems. So, first, we are going to look at a very basic equation. Let's say f of x equals x squared plus 2x plus 3. And we are asked to find the equation of the tangent line at the point, let's see, let's pick a nice number here. Let's just do at 2 comma, looks like that'll be 11, 4, 8, and 3 at 2 comma 11. Okay, so as with every line, it's useful to recall what we need in a line. We need to find slope, and we need the y-intercept. And you can use the slope-intercept form as I wrote over here, or you can use the good old point-slope form. Either one doesn't matter. Regardless, you need to have the slope and you need to have the y-intercept. So it's important to understand that the derivative is the slope. Derivative is slope. Now, when we find the derivative and we have a variable like an x in there, we're finding the slope of any point x. Okay, but now in this particular problem, it's not any point x I'm referring to. I'm referring to when x is 2. So we're going to get a numerical answer here as opposed to an equation with an x in it. So look at our original function again, f of x. The derivative of f of x is simply 2x plus 2. Well, at that point, and notice the notation, because I will be a stickler for notation, f prime of 2. Okay, so what this is really saying is the slope at 2. Okay, so let's just scroll down here a little bit more. This is the slope at 2. The slope of f of x when x equals 2. This is the equation to find the slope of f of x. Okay, so f of 2, we're literally going to plug in to f prime of 2, I should say. 2 times 2 plus 2. That's a lot of 2's there. That is 6. So think back to Algebra 1. We need the slope, we need the y-intercept. Well, I got the slope now. My slope is 6. And I like to, just so I know what I'm talking about, I like to do a subscript of tan. The slope of my tangent line is equal to 6. So now when I'm trying to find the equation, I got two options here. I prefer the point slope method. So I'm going to do y, and I'm going to write tangent because this is not my y equals. Right, this is the equation of my tangent line. Y tangent minus, well, my y value, notice, is 11, equals my slope of the tangent, which is 6, times x minus my x value, recall, was 2. So the equation of my tangent line is 6 times x minus 2 plus 11, or if you distribute and solve a little bit, you get 6x minus 1. And that is the equation of my tangent line. All right, pretty straightforward. But let's look at a little more difficult of a derivative, one that includes a product rule or a quotient rule, or even some trig functions perhaps. Let's say g of x, and let's say it's sine of x times cosine of x. And we want to find the derivative, find the tangent line rather. I said derivative. We want to find the tangent line when x equals, and let's find something that works out kind of nice here. What is pi over 4 going to do for us? That looks like it'll be kind of nice. Okay, when x equals pi over 4, or, you know, I could have said, or at the point pi over 4 comma, I believe that would be a 1/2, right? Because that's root 2 over 2 times root 2 over 2, which is 2 over 4, which is 1/2. Okay, so again, we have to go through with our derivative here because we know that derivative is slope. This requires a product rule. So we have f g prime, there's f. G prime is negative sine plus g f prime. And f prime is cosine. So I actually end up with negative sine squared plus cosine squared. Well, normally we might simplify this and replace cosine squared with 1 minus sine squared, or maybe we'll replace sine squared with 1 minus cosine squared, but I'm not actually taking the derivative and simplifying the derivative. I now want to take this a step further and find g prime of pi over 4. So I need to plug in pi over 4 for each of these. So recall that the cosine and the sine of pi over 4 is root 2 over 2. Okay, and that's from our unit circle. So g prime of negative 4, again, notice notation. This is g of x. Now I've begun my derivative. I'm still in my derivative. Now I'm evaluating my derivative. So if sine of pi over 4 is root 2 over 2, this is going to be negative root 2 over 2 squared plus root 2 over 2 squared. So I end up with negative, what do we have there, 2/4, and positive 2/4. That looks like a 0. So my equation now, and recall, that is the slope of my tangent line. So I have y minus pi over minus 1/2 equals 0 times x minus pi over 4. I simply have y equals 1/2. That's the equation of my tangent line, and I got a little distracted there. Should have put my notation for tangent line. Now this is interesting, and I'm going to have to pull a graph up for this one. So let's see how this appears on the video here. Give that a second to pop out. We're actually going to graph g of x and 1/2 x, and we're going to confirm that in fact y equals 1/2. I believe I said 1/2 x. Y equals 1/2 is in fact a tangent line. That's a horizontal line at 1/2. So while we're validating the software here, all right, so let's go to our y equals, and we're looking at sine times cosine as our original function. Sine of x times cosine of x. I want to make sure my mode is in radians, and I am. My window, I want to zoom. Actually, my window, since I'm looking at the point pi over 4, I'm going to go from 0 to pi over 2. And that way pi over 4 is going to be right smack in the middle. And in fact, I'm going to go by a step of pi over 4. And then as far as height is concerned, well, my equation is y equals 1/2, so I don't need anything bigger than 1. And this way 1/2 will be right smack in the middle as well. And I'm also going to put y equals 0.5, 1/2, right? The equation of my tangent line. Here comes my graph, and my tangent line should smack it right across there, and look at that. That is phenomenal. That is some good stuff there. Let's drop this in here. And there's the equation of our tangent line. And a little bit more math there for you guys. All right, it was nice teaching you today. We'll pick this up again tomorrow.